Our first speaker is Gwoźdź from Neoteric, and he's going to tell us something more on how can you build a customer churn model which can also identify reason for churn. And welcome, Grzegorz, on the stage.
Okay, let's begin. A few words about me. I'm CTO at Neoteric. What I'm responsible for in our company is first of all knowing how the hell everything works. My specialty is everything what we do related to data in AI. I help our customers get more information from the data they already have and predict what might happen with them. So, few words what the churn is actually is. Before we continue, do any one of you have already built predictive models or work with churn? Okay, I'll start at the very beginning. Churn, in short, is proportion of how many customers you're losing every period of time. Usually we measure it in months or over a period of a single year. Important thing in here is that losing revenue and losing churn might not actually be the same thing. You might lose your least valuable customers and still be growing in terms of revenue, and you might be losing a lot of revenue from your top customers and keep onboarding the smaller ones. We might think that bringing on new customers might help, but it's actually not a good strategy. With churn and customers leaving, we're struggling with few quite difficult problems. First of all, when customer acquisition costs are growing, the cost of every churning person gets higher and higher every month. Second of all, if you're thinking about good evaluation of your company by investors, churn is one of the most important metrics they take into account. Finally, it takes huge impact on both customer lifetime value. And if you don't know what you're doing with churn and you don't take preemptive actions, you're gonna lose a lot of those customers. I especially recommend reading more about how Salesforce transformed into subscription-based company and how they struggled with it. Okay, so how do we build such model? First of all, you need to know a lot about customers. Everything that has impact on your interaction might impact churn. From what we've seen so far, your first piece of data is knowing what people you're working with. Are they young? Are they old? That data, the demographics and related ones, are usually available on the market, and even if you don't have a lot info about your customers, the data is easily purchased. Then purchase history, and by purchase history I mean everything related to transactions, what your customers do around your company. What they have purchased, when they have purchased your products, which one, at what price, with what discount, how the invoicing looked like, what were the terms of payments. Then everything related to activity and how they use it. Speaking about telecoms, that one of our child companies specializes in, everything what people watch, what they might want to watch, their preferences, for example, from FieldMap or any other related portals might get useful. than the trainings that those people have taken. You probably, when creating products, you do some onboarding. You teach those people what they do. They register for webinars, and each of those activities should be recorded in your customer profile. And finally, something that, especially in big companies, is extremely difficult to track: everything related to marketing and communication. That piece usually stays in the depth of marketing department, and IT never sees it. You have to do everything to get information who was targeted with email campaign, if those emails were opened, if any SMSs were sent, what they do with customer feedback responses, and combine all of that data together. Once you combine the data together in a single profile, you're stuck with GDPR regulations. It's a tricky thing, and it introduces a lot of problems for marketing companies. The easiest thing to do when building models, your models never care if your customer is named Grzegorz Gwoźdź or ASDF. That means that if you anonymize the data, even one way, your models would never would treat the data as just being another person. Another option is simply dump personal data and never use it in your profiles. That gives you huge amount of data about behaviors, about purchase history, and once you have all of this information together, without personal information, that's something that you can put somewhere out there and use for building models. Important thing before we build those models using the data. With churn, you usually get a little bit less than 1% of churners every month, and if you prepare data like that, your models, which basically learn what everyone else is doing, would consider your model good enough if it tell you that no one would ever churn, and that would give you around 99% of accuracy for your model. That problem is called accuracy paradox, and in order to prevent such thing, you need to balance your training data. If you look, so that's how your churner database usually looks like. It's only a small fraction of churners that you're trying to track. And with any other product purchases, it's usually get much easier. That small red thing usually gets omitted, and you want to do everything to prevent such behavior. Easiest thing is to use other thing than accuracy to score your model, which is actually a good thing. But before you start, you should consider something called resampling. Resampling is a technique that allows you to create virtual churners so that the red thing would grow significantly. And because you're basically cloning people that you labeled as churners, you're not introducing any problems or any anomalies in your data. You're just making sure that both data sets are roughly the same size. Next thing is choosing which algorithm we want to choose. Everyone knows that all the cool kids use neural networks and especially deep learning, but that might not be actually the best case in here. Neural networks take huge amount of time to build, and you will be working with extremely large data sets, especially with churners. You would be tracking probably millions of your customers, storing the view or the snapshot of the profile for every month of the activity, or even every day of the activity. Training neural network on something like this would probably take weeks, and the cycle of the training would be pretty much impossible. Speaking from the higher view of what models we have available in machine learning, those are first of all clustering models. They would divide your customer base into few most popular profiles. That's actually pretty good thing to do before you continue, because once you have the churn predicted, you would be able to nail it down to few of the most common traits or most common personas that you know that are most prone to churn. Second type of models are classification models. Those models are telling you, I'm either doing this or I'm either doing this. Subclass of this is just having multiple of those classes. For example, determining what number we're seeing on the image. Last piece is guessing how many or how much, and those are various kinds of regression models. With churn, and especially with decision trees, I strongly suggest using a model called two-class boosted decision trees. Sorry, but I can't remember who was the guy that invented the model. A rule of thumb in determining yes or no questions is using two-class boosted decision trees. That's the first model you should go to, and only if you're not able to tune it, then try it with something else. Biggest advantage of that model is that first of all, it has crazy high accuracy. It has a short training time, but it consumes huge amount of memory, which is not your problem if you're training your models in the cloud. And finally, if you want to know what's happening in your data, decision trees, in contrast to neural networks, can be visualized. It would look something like this. When you're training decision trees, you're building various kinds of similar trees. First one is the most important one. The second one corrects errors from the previous one, and that gives you a chance not only to get really high accuracy, but on the other hand, visualize those trees, which are basically sophisticated if-else statements, and know what's first of all causing your customers to churn. Once we build a model, we need some way to actually know if it's working. There are a few metrics that are being used. We've already mentioned accuracy, which is usually a crap, and no one uses it. Accuracy tells you how many percent of each profiles were predicted correctly. It rarely gives you valuable information. What you're mostly interested in is recall and precision. Speaking about churners, recall tells you how many of all the churners in your profile database you have actually found with your model. Precision, on the other hand, tells you how many of the ones that you have found are actually churners. That's strongly related to true positive and true false metrics. You would be tracking how many of those models were marked as true and are actually true. How many of the ones that you marked false are actually false, and that's the single most important thing you should actually track. With churns, I strongly recommend optimizing for recall. Losing the trade-off you're doing in here is usually I either want better precision and know that this guy is for sure churner, or I either want recall and know that I've got all the churners. When the cost of losing customer is really high, you want to get all of them. On the other hand, with the case with precision, that's the case when you're analyzing radiology images, and you don't want to tell each and every person that might have cancer that he actually has has cancer. Evaluate model. Okay, next thing that we need to do in here is actually deploy and update that model. With Azure ML Machine Learning Studio, Google AI something, and Amazon Machine Learning, the process is actually pretty simple. You spend huge amount of time on preparing the data. You upload the data into the cloud. Tell which model you want to use, and everything. Leave for a day or for a week, and when you get back, the model is ready. Once the model is ready, it's available in some kind of as a form of endpoint, and you usually get three types of endpoint. First one, the transactional scoring API. If you want to score your data very often and very small batches, that's the way to go. It's for single transaction and real time scoring, and it's crazy expensive. With batch scoring, you're dumping all the data you have that gets scored for a couple of minutes or a couple of hours, and you get all the information back about your whole profile database. You might consider sending updated profiles to your models, and that's the retraining API. It allows you to update the scores, and once we get in here, it updates all those values, and it's surprisingly not really a good idea to do it. When you update your models and you get new sets of data, you would probably need to change some of the attributes, introduce new ones, and updating models in such way that you're just sending new batches of data doesn't really work. It's much faster and much easier to actually rebuild whole model and deploy it once again. We might talk about something also called hyperparameter tuning. When you build models, you're selecting a whole bunch of information which you want to take into account. Those are your called attributes. You determine what's the label, and that's the attribute you want to predict, and guessing which piece is which attributes to use is surprisingly difficult. Hyperparameter tuning, ditching all the theory and mathematics, is a smart tricky box that tells you which of those attributes should actually be selected. The metrics you're seeing in here, there are a few others, but for now, those are the most important ones. Are the ones you'd be optimizing. With those online tools, you're just saying, I've got this bunch of data, I want to predict this attribute, And please optimize on recall or on precision using this measure for error. It obviously takes much longer, but the models are then really accurate. Summing up the whole process. First, you're collecting everything you know about your customers. I strongly suggest using some kind of streaming APIs. Especially, what really worked for us was HWS Kinesis and Kafka Streams. Then you need to store those profiles that get updated with every event in some kind of database that gets easily exported. You might remember that you'd have large amount of data. So I'd suggest, and the data in schema changes very often over time, so I'd suggest using some kind of NoSQL database. DynamoDB really worked well for us, and obviously MongoDB is web scale, so everyone should use it. Then you do the balancing all the training data. Once you've got your training data ready, that thing gets done pretty much automatically. It just needs some tuning. Then you train the model and deploy it in some kind of web service, and you score your profiles using those models. You might talk with Kuba Wszołek, who's running around here. Your models are basically small applications, and it's very often much easier to transfer those small applications around multiple servers than to transfer the data. Kuba is one of the best experts regarding Hadoop platform I know, and I'd strongly suggest talking to him how to deploy such thing. Then, extremely difficult thing to do. I think it's even more difficult than actually gathering the data and preparing it for training. Is distributing it in a form that people might actually use it and understand it. That means working with people we all dislike, which is customers or users. That piece requires us to work with them, that they should not think of them as experts, but more kind of like scientists and people trying different things. People have habits, and